Writing and evaluating a function modeling continuous exponential growth or decay given doubling or doubling time or half life. Um, and so this could go either way with this particular topic. We'll show you the way that's here and highlight what we're doing. So first of all, continuous exponential growth. That's this italicized. That's what we're focusing on. And it means we're going to get an equation of something times e raised to this power. And just from the, hopefully from the before, you see that the number in front is always what we start with. That's our starting value. And the value here in front of the exponent, up in the exponent, that becomes our rate, or that is our rate as a percentage. So it's a percentage rate. If it's negative, it's decreasing. If it's positive, it's increasing. Now, when we got here, we're told we have doubling time. That means we are growing. We are whatever we're starting with becomes double what we started with after 17 hours. That's what doubling time means. So after 17 hours, we have twice as much as what we started with. Here's our initial value. So we've got a lot of information already pre-given to us. We know we're starting with y equals 34.4 e to some rate times its time, rate times time. But there's just too many variables here, and so what we're going to be able to do is we're going to be able to put things in. So we know the time, the t is 17 hours. And in 17 hours, we will have double what we started with. So we started with 34.4. To double it, we just multiply that by 2. And we get 8, and 3, 6, 68.8. So now we can kind of come here, just save ourselves a little room. We know what y is when t is 17. So we replace those values, right? We know this is 68.8 when time is 17. So now we're down to just the one variable. What is the rate? That's all we got to find. And notice we had to find this 34.4, but it was given to us. We just needed to know that that is the initial value, the starting rate. So we got that to put in. So while we're at it, why not? I'll go ahead and plug that in there. 4.4. Now we just need to find the rate. And again, we could do this in multiple ways. Remember, that's going to be a percentage. So like if it was 10%, the value of r is going to be 0.1. If it's 20%, it'll be 0.2. If it's 5%, it's 0.05. So it's a smaller number. We could do this graphically. Let's go ahead and start with that, graphing each side. So I would say first is y is equal to 68.8. Why is it doing that to me? Oh, 68's way up here. So again, I gotta, that's one thing, is you gotta get your window. Here we are. So that at 68, I'm way up here. I see that's going to give me my horizontal line of my answer. And then I put in this other equation, actually, as y equals. That's how it's going to graph. 34.4 e raised to the r. We use x for the r because that's what we can do. Shift. And I'll do it as 17x, right? Because that's what we've got here. 17 times r, or r times 17, or 17x. Yeah. And so now we click here, and remember, it looks like, well, that looks like it's right on the y-axis. It's not quite, but it's very close. So our value for r is right here. That's 4%, right? Move the decimal over 2 places. But just notice, we might have expected it to be further to the right, but no, it's going to be very close to the y-axis already. There it is. And they want us to do it. Write the formula in XY. Use exact expressions to fill the missing parts of the formula. Do not use approximations. Okay, now we're in trouble. The problem is this gives us an approximation, right? 0.04077. That's an approximation because it's actually got more decimals over here. We're going to have to round this. So that's an approximation. They don't want an approximation. But what this does is it gives us a way for checking our answer when we get that value. So we're going to do this analytically. We're going to solve for r, and so our answer is going to evolve like a natural log and such. But now we have a way. In fact, let me put that there. Let's label it so it's going to be there for us. We have a way to check our answer. Okay, so first thing we're going to do is we've got to isolate the exponential part. So we'll divide both sides by 34.4. And don't be too surprised. We should get that 68.8 divided by 34.4 is going to be 2. That's always, and you'll see once we do this, it kind of naturally happens. I'm going to write this as 17r, where the 12 came from. You could take the natural log of both sides, or you can do the log dance, right? I like just sticking with the log dance. So it's a base e, so that means it's natural log of 2, because logs have to switch here, equals the exponent of 17r. I keep going. I said 17 and I write 12. Sometimes a hand has its own brain in there, I think. And then what we're going to do is we're going to divide both sides by 17. So r equals natural log of 2 over 17. This is our exact answer. And what you're going to see is if you put this in, it's also going to be 0.04077. So one way to do this, we come up here, right? Put in the natural log. Natural log of 2 divided by 17. And that's the same value. So we know we're on the right track, right? And got this long one, but hey, we got the same decimal answer, but this is the answer they want, the exact answer. Now, oftentimes we think, oh, decimals are more exact, right? No. Decimals have to be rounded. They're not exact, they are rounded. This natural log of 2 to the 17th is an exact answer, and then you can choose the level of accuracy that you want. If you want 57 decimal places, you could get it with this particular answer. But this is the answer we're going to put in, natural log of 2 divided by 17. So we come here. That's what we're going to put in. And we've got things here. So I'll do the fraction first, and then the numerator, we're going to go natural log of 2. The denominator, we're going to put 17. Okay? And I'm just going to clear out a little bit of this stuff like that so we can see it clearly. Okay. And then the second part of the question is going to ask us to say, well, how much will there be in 5 hours? Well, certainly less than half, so certainly not 68.8. But what we do is we just take our equation now and we plug in 5. In this one, we want it rounded to the nearest tenth. So the thing is we actually, in graphing it to get our approximate answer here, the approximate answer to check, we could actually just change this, because now we want to know, well, actually we can't, we want to know that when x is 5, what is the is 5, what's the output? So we could just come up here, and I guess the quick and easy way is we could change this and just put a 5. I'm going to take off this y, change that x to a 5. I got to put times 5. There we go. And what I get is, what will the area of the sample be in 5 hours? Oh, no, no. Okay, I see what I did wrong. Um, the 17 is 17 hours. I want to put the 5 in for the number of hours. What I had, so I got to change this a little bit. That's where I was thinking. Okay, I went um, thinking through this. I need to have this natural log of 2. We'll do this without any rounding. I can just type it in. Divided by 17. And then I'm going to put the 5 in for t. So 5 goes here. Notice, and that makes it a little bit more, I knew it has to be more than what we started with because it's going to grow, right? But it has to be less than the 68. It's going to be 42 point, how much nearest 10th, 0.2, because next to the 1 here is a 7, so it gets rounded up to 42.2. 42.2. Okay. And if you wanted to, you could use the graphing method. Again, this is sort of like the easiest way because we're just solving for one thing. If we need to solve for multiple things, instead of putting a 5 there, we might put the x and actually have the graph y equals. And then what we would put up here is we want to find out when x equals 5. What do we have? Get rid of some of this other stuff. And we could do this graphically. Again, we have to go down here. Here's our x equals 5. Here's our equation, our growth equation. And when we click here, we get 42.2. Okay, so that's another way to do it. Again, just the more you do these things in multiple ways, the deeper your understanding is going to be. But again, on the test, yeah, just use what feels best to you, and you're going to have that way. Okay, thank you. That's it. We're done.